Ladies and gentlemen, I am very pleased to welcome you to this EDF group session on flexible operation. I am Bernard Legren, Vice President for International Affairs at EDF Generation. And I am really pleased to be with you today for this important session that will explain how the flexible operation nuclear reactor is feasible and can help to meet the challenge of climate change and to leverage the complementarity of nuclear power, renewable energy, and energy efficiency. So let me introduce you our two speakers today, two senior experts from EDF and Framatome with a huge experience on this topic. Our first speaker will be Stephan. Stephan has worked 20 years in EDF NPPs at various levels, from operating engineer to deputy plant manager. And since 2012, Stephan has been senior advisor and fellow expert group for operations and flexibility for the whole EDF nuclear fleet. And Thibault Gain, our second speaker. Thibault has worked in the nuclear industry for over 30 years, occupying notable positions, including project manager at the LAG processing plant and senior design expert at WNE. Since 2016, Thibault has been a senior expert and technical advisor for Framatome. So, Stephan and Thibault, you have the floor now.
Thank you, Bernard. The French minister said this morning that nuclear energy and renewables are complementary, and we are going to show you how we can be very complementary. It is even more true when nuclear is flexible. So why being flexible? In the electricity mix, we have wind power, solar power, which are variables, energies. And let's assume that we have nuclear plants. Of course, depending on the weather, you have more or less wind power or solar power. Let's talk about solar power because it's very regular. Every day at noon you have some solar energy. And you can see on this figure, on this slide, we don't see on the slide, sorry. On the right part, the yellow curve is the amount of solar energy within a day. And in blue, it's the amount of other energies. You can have coal, gas, but you can have also, of course, nuclear energy. And as the total must respond to the need of the grid, of the consumers, you have to adapt the generation of nuclear power plants facing the increase of solar energy. In France, we have some experience with flexible power plants because we have done that since the 80s. Not because of renewable energies, it was not the issue at this time, but because of a large amount of nuclear electricity in France and in front of variations of consumption. At the beginning of our fleet, our reactors were operated in base load, but soon we were able to operate them in a flexible mode. I would say that all reactors, thanks to their basic design, can be flexible, but we enhanced their flexibility thanks to modifications implemented with Framatome. And today we operate all our fleet in a flexible mode, I will say successfully, and we know that tomorrow it will increase because we made some studies with our research and development department showing that this need is going to increase. You can see on the top right the amount of nuclear generation within a week. It was in March 2019, for instance, but it's not important, the date. You can see that we made up to 20,000 gigawatts of variation in a few days. Another example, another day in April the 5th, 2020, it was during the first lockdown in France because of COVID-19. And you can see the electricity mix varying. At the beginning of the day, a lot of nuclear energy, some wind, of course, no solar. At the middle of the day, you can see in orange the amount of solar energy. We have not so much solar energy in France for now. It is increasing, of course, but it is necessary to reduce our power at noon and in the beginning of the afternoon. On this day, 19 of our units reduced their power and were able at the evening, during the evening, to go back to full power. It is very important because, of course, at 7 p.m. you have no more solar energy, but you have a peak in consumption, so you need to increase nuclear energy at this peak hour. And amongst the 19 units performing those variations, 6 of them were black rods units. I mean by that, they had not been modified by Framatome. It is a basic design, so it shows you that it is possible to make flexibility thanks to basic design nuclear power plants. I didn't say that all our power plants are pressurized water reactor. Another example, so I think it's difficult for you to see because you are far from the slide. Our typical performance, we can vary our power twice a day. We can go down to 20% of nominal power. And it takes only 30 minutes, half an hour to go down, and also half an hour to go back to full power. In blue, you can see the shape of the power of one unit, one specific unit during 1 month. So you can see that we can do that every day when it's necessary. And on the map, you can see France in green. The map, I think you know this app, electricity map. You can see the amount of CO2 per kilowatt hour, and you can see that France, like Sweden or Norway, are always in green because we emit very low CO2 generating electricity. Sorry, it went too fast and now too slow. So I wanted to talk about the impact of flexible operation, mainly to say that there is no severe impact, no really noticeable impact. Of course, we talk about safety. We have made safety studies showing flexibility is possible. We pay attention to the fuel. There are some limits, but they are very far. We can do a lot of flexible operation with our fuel. It's not an operational limit, it's only theoretical. About waste and environment, no noticeable impact. We release more water, but no more reactivity, no more radioactive elements in the environment. One important point is chemistry. You need a good cooperation between chemistry department and operation department because each time you change your power, you change the equilibrium between boron and lithium, for instance, in the primary circuit, in the core, so you have to adjust them. There is no really additional maintenance, maybe a few, but it's not a lot. It is cost effective because we generate less electricity when prices on the market are very low, and we're able to generate this electricity during winter, for instance. In France, during winter, we have higher consumptions, so prices are higher too. So it's cost effective for us. It's profitable to choose the time when we want to generate electricity. And one important thing is skills. You have to train specifically your operator, your control room operators, to flexible operation. And now, Thibault.
Thank you, Stephan. So the main question for us is why no? Why not in the past? Why not in the future? Except EDF. In fact, we had two main facts happening in the last 2 years. The first one is the COVID pandemic. During the COVID, the electricity demand drastically diminished, was reduced. And so most of plants have to reduce their output because lack of demand. Second point, recently the prices of fossil energies increased a lot, making nuclear more profitable for the spot of electricity. And so you have to keep in mind, nuclear is between renewables, very low costs, and fossil, high cost. So nuclear has to adapt from the top to the demand and from the bottom to the increase or decrease of renewables. Nuclear in between. EDF is perfect for that because nuclear is 70% of the total grid. And so EDF is permanently adapting like a pump, I would say, the nuclear generation. It was well. So, in fact, why you operators should consider nuclear generation? The first most important point for economical issue. In fact, flexibility is profitable. When prices on the electricity market are low, you reduce. When they are high, you increase. And you increase before fossils, which are more expensive. So it's much more profitable for operators to be flexible with nuclear generation, particularly with the advent of solar. Solar is only producing during daylight, maybe with the moon. I don't think it will be very efficient. So in the night, zero. In the day, maximum. So in the day, you are in over capacity. In the night, you are in lower capacity. And the spot is calculated hour per hour. So in the night, prices increase. In the day, they decrease. So if you adapt nuclear to demand and renewable generation, once again, you are more profitable. So economics first. The second one, very important, more and more and more important, carbon emissions. Nuclear being flexible with the same performances than fossil, gas and coal and oil, better than coal, equivalent to gas, better than oil, takes the place of fossil in the grid, lowering the CO2 emissions. Easy to understand. And last, not least, in fact, you have to keep in mind, most operators I met are convinced it's not possible to perform flexibility with their plant as is. It's wrong. Without INC modification, INC strong modification, without any other modification, you can perform flexibility without fuel impact. We, EDF Group, were there to give, to sell, to give to you our feedback with the solutions you will be able to implement. Framatome for the core solution and EDF for the training, I would say, the support to operators, because it's easy to upgrade the plant. It's less easy to, I would say, train operators. So EDF have years, thousands of years of experience to train nuclear operators to be flexible. Second point, in fact, nuclear, a few years ago, was not really in the scope of operators. Now, it's a worldwide perspective. in US, in Asia, in Europe, everywhere, people understood a flexible nuclear is a way to keep nuclear profitable with a safe generation of zero CO2 carbon emission. And so, to conclude before, not yet, EDF and Framatome, we can bring together to you, operators. EDF is currently performing the top of level flexibility. What I mean with that, EDF is performing frequency control, first reserve, secondary reserve, load follow, load shedding, load reduction. Everything is possible with nuclear in France. Other operators operating in base load. No problem, no worry, no burden. In between, the gap is huge. So we, EDF Group, we thought with you, you start from the bottom, base load, and step by step, you reach the full flexibility. And the first level is to be variable in base load. So steady state, reduction, steady state, back to power. Before performing load follow, and before performing potentially frequency control. And the first level is without INC modification. But you need training, always. And so, Framatome, the technos, the solutions, EDF, the support, the feedback, analysis, and training. It's a global approach. Last not least, what is important on this graph, I'm on time. Baseload, current baseload. Current EDF performance is inordinate is the impact on the system, level of modification. In abscissa is the flexibility level. What we aim at achieving in the EDF group is to improve the level of performance for less impact on the system. And being completely flexible will be done with less modifications than the current system, including in base load. So meaning, once again, it's very profitable solutions. Hope it's clear, so I give back the floor to Stephan.
To sum up our subject, well, I hope we have shown you that flexible nuclear is profitable. For EDF, it is. You have to make sure there is no issue in regard of your equipment, for instance, but we have some experience with that. We have a lot of data because we have hundreds of fuel cycle being flexible. So we have a lot of data, a lot of observations with link or no link between discrepancies, for instance, on flexibility. And I would say that there is quite no link between them. We propose customized solutions in INC. We propose qualification of different solutions using the input of analytics solutions that I've taken just before. And from the least demanding operating mode, as my colleague said, you do not need the full scope flexibility. And we propose licensing, qualification, and transient management, and assistance and support solutions, thanks to Framatome and together with Framatome. And as a conclusion, I would like to thank you for your attention. And I hope you are now convinced that nuclear reactors are flexible. If they are not, it is because you don't want them to be flexible. But if you have the opportunity to do so, you can. And EDF Group, EDF and Framatome can help you by providing solutions tailorable to your needs. I would say we are flexible to respond to your need. Thank you.
Thank you, Stephan and Thibault, for your contribution. Well, on the screen, you have the take-home messages on this conference, but just before the leave, we have just time for one or two questions. And my first question for you, with your experience, if I am an operator, what is the first milestone I have to reach to develop the flexible capability of our baseload nuclear power plant? Who want to answer?
I would say you have to pay attention to skills, control room operator skills. As we said, basic design is sufficient to be flexible. So, of course, you have to make sure that your safety studies are okay with that. But the main change is about operators' skills.
Okay, and my second question, during those 3 days, we talk a lot about hydrogen, we talk a lot about battery. With advances in battery technologies, we will be able to store more electricity in the next future. So do this new electricity storage solution become an opponent or an advantage to the nuclear power plant's maneuverability?
My opinion is that in the future we will need all the flexibilities that are available on the grid. Flexibility from nuclear power plant. If you have hydrogen, it's okay. You can add more flexibility into the grid. You can have flexibility from the demand, smart grid, and so on. And I'm convinced because you will have a lot of renewable and variable energies. Sometimes difficult to predict during the day or for tomorrow or within the week. You will need a lot of flexibility. So there is no competition between those sources of flexibility. They are also complementary.
And I would like to, Stephan, this is the operating point of view. And from a technical point of view, in fact, if you introduce hydrogen next to your plant, or it can be connected to the generator, it can be connected to the grid. If it is connected to the generator, you introduce new transients. I mean, when you switch from full electricity to grid to half grid and half to hydrogen generation, you have a transient. And the systems are here to stabilize the core in case of transients. So making operators cool in the control room.
Thank you again, Stephan and Thibault. We are reaching now the end of this workshop. I have two final messages. We have, if you wish, a slot of 30 minutes just close here. For more questions, we will be there. And my second message, please do not hesitate to come on the EDF stand and Framatome stand. We will be able to give you more explanation on this important subject and also on other subjects. So thank you again for your attention, and I wish you a great WNE Congress. Thank you.
Thank you very much.